This conference will now be recorded.
Yeah, it's getting recording now. So hope you guys can see my screen. So before starting this, let's just recap for a minute what we did. So yesterday we started with this heuristic algorithm inside the supply chain module. So heuristics generates a supply plan. Um, once we feed the demand into the once we feed the demand into the system, and once the supply chain model is in place, when I say a supply chain model, I mean all the DCs and locations and how they are interconnected, and how they're connected to the customers, and where the production is happening, and how many resources are there, and etc. etc. So once you have your supply chain network, and once you feed in the demands, and once you run this heuristic algorithm, it generates a supply plan. It generates the production plan, how much to produce, where to produce. It generates a transportation plan, how the stuff has to move between the locations and ultimately to the customer. It generates a purchase plan. It generates the uh, projected stocks, how much stock has to be made available at a particular location, so that it will meet the demand and etc, and meet the safety stocks and etc. We can also see the capacity utilizations, and those are the major supply planning outputs that we can analyze by running the heuristics. And yesterday we have also seen that heuristics primarily works on quota arrangement. So the planners has to manually go and specify what is a quota. Like if a warehouse has a two sourcing options, a warehouse is connected to DC1, DC2. As a planner, he has to go and say how much the warehouse has to source from warehouse 1, zero point 0.5 or zero point 0.4, and how much from warehouse 2. And the summation always has to be 1, not more than 1. If it is more than 1, heuristic will fail, and it is generous enough to point out the locations where the quotas are exceeding the summation of 1, so that we can go and adjust them and rerun the heuristic again. What else we have seen? So yes, yesterday we have also seen that the quotas need not be a static value. They need not be fixed for the entire horizon. So for that, we just need to do a simple master data setting. We need to go and say that these quotas, we have to make them as a time series indicator by enabling it, by marking it with capital X, by maintaining a alpha value of alphabetic value of a capital X. Then we save it, and then the heuristic algorithm will stop reading the quotas from the location source master datas. Instead, it will read from the key figures called as a location sourcing ratio. So there are quotas at three different places. So first thing is there is a quota at customer source. Like a customer Amazon is connected to three warehouses, you can go and specify how much of warehouse 1, warehouse 2, warehouse 3 has to get sourced. So that ratio will be maintained in the master data called as a customer source of it's called as a customer source, but the business description, but the full name is customer source of supply. There is an attribute in there. If you want to deal with the key figure, the relevant key figure name is customer sourcing ratio. If it is from a location standpoint, the ratios in the master data is available in location source. If you want to refer it from the key figure, then the key figure is location sourcing ratio. I mean, the USP of the key figure is, we all know it, it's a time series based. So every key figure for its particular base planning level, it can have a varying values across the time horizon. So if I'm dealing with the key figure, I can very well say for the first 10 weeks, I'll give point 0.1 and point 0.9, and after 10 weeks I'll give point 0.5 and point 0.5, and then you can play around. And if it is a if it is a key figure, you just do a change, and then you can simulate, and then you can see the new results, and basically you can perform what if analysis. What if my ratio is this for this particular node? What is my new supply planning result, etc., etc. Third place where you apply these ratios is from a production perspective, and that is in the production source header. So this is where you maintain your BOM data, and in IBP language we call it as a source IDs. You say that inside this production location for this particular product, how many production versions are maintained. That means how many source IDs I can maintain. So now, if there is a demand for a particular product one, and then I have a three source IDs available, I can manufacture it in three different ways. So now again here you can put some quotas on which source id has to be picked, and how much weightage we have to give to all the source ids. If I say point 0.2, point 0.2, and point 0.6, if the demand is of 100 units for that particular product, for the production version 1, the production plan would be of 20, production version 2, 20, production version 3, 60. So based on the ratios, it would get split. So if you want to maintain that quotas, you have to go to this master data and maintain it in the particular attribute. If you want to deal with the key figures, the key figure name is production sourcing ratios. So we have seen this yesterday. um, so so now guys, I have come up with some scenarios. So, like we'll keep on covering scenarios as we move forward, because we have a supply propagation heuristic, another kind of a heuristic, and then we have the optimizer itself, the big giant one. So yes, we'll try to cover different scenarios, but from a heuristic perspective, these are the scenarios. We'll touch base them, like a quick overview on what kind of scenarios we're touching. So first scenario is the in-house versus external production. Okay, this is the network that we have built yesterday. So on to the right hand side we have the customers, Amazon, eBay, and Amazon is connected to two locations, warehouse one, warehouse two. I think the diagram is not proper, guys. Just please spare it. And the eBay can also get stuff from warehouse one, warehouse two. Warehouse one can get it from plant one and plant two, and both are connected to a supplier called S11 Intel. And Intel is basically shipping the chips so that the plants can take those components and produce the finished good called S11. And S11 is a product, a finished good, a smartphone. Series of 11, and that is a product that we are playing in. So this scenario, what I'll do is I'll bring up another co-packer or a co-manufacturer, who's not, let's say, who doesn't belong to our, I mean, they obviously belong to the supply chain, but we don't manage it completely. So that means we don't want to do the capacity planning in the co-packer, right? So we know a co-packer, it's an external kind of a vendor. So I'll just tell my co-packer that, okay, I need this much, can you please do that, and they'll do it, and then they'll ship it. So, and we assume that that they have a kind of enough capacity all the time, and like yeah, so they have enough capacity. And then, so basically guys, when you don't want to plan for the for the co-packer, and you don't know what kind of a bombs that they use, what kind of a source site is, sorry guys if I'm using the terminology of bomb, because I'm used to take sessions for the ECC audience much. So yeah, that's why I use the terminology bomb. But yeah, whenever I say bomb, just think of the terminology called source ID. So yeah, so when you don't want to configure the source IDs for the co-packer location, And when you don't know what raw materials requires, what raw materials the co-packer requires, you don't know, and you don't want to know about it. So you don't want to plan in detail for the co-packer. So in that scenarios, you can just create a location and then map it, and you just extend that material, you establish a transportation line. That's it. Okay. And then we need to specify the quotas, so that the so that a split of the demand from the plant one. Let's say if I'm connecting the co-packer to the plant one, if the demand is 100 on plant one to produce S11 product, now I can decide that how much I have to internally produce, or how much I have to go to the external procurement, right? And then there are other ways to influence it, not just the quotas. It's not always quotas, right? Sometimes we have we will have some kind of a hard rules, which we want the system to adhere to. We'll see all those stuff also. So that's the first scenario: in-house versus external production. Second scenario is lead times. Yesterday we haven't touched based on the concept of lead times, so today we'll introduce the lead times into our supply chain network, and we'll see the impact of the lead times. And especially I want to touch base on from a transportation perspective, that if it is a 2 week lead time, when the shipment will start, and which key figure I need to refer to see the shipment from a shipping location perspective, and when will the goods will be received, and what key figure I need to refer to see when the goods will receive. And that is from a destination location perspective, receiving location perspective. For example, the plant is sending the goods to the warehouse. So now if the planners inside the plant, when they want to see when the goods are moving from the plant, and there are particular set of key figures they have to refer to, so that they'll know that okay, on week 1 the goods are moving in. If the planners from a warehouse, if they want to see like how much of the stock that I am receiving in, so they will look from their receiving location perspective, and there they will see the goods getting received on week 3. The goods will start on week 1, they receive it on week 3, and in between they're in transit. And then there are two sets of key figures where we have to see from a shipping location perspective, and from a receiving location perspective. And then the lead times comes in between, and then the lead times would do an offset of this entire shipment plan. Third thing is manually adjusting the plan. Sometimes we receive a particular a input. For example, in this scenario, that the co-packer might send an email, or the planner somehow knows that on week 10 I can give you only 10,000, please don't give me anything more. So if that is the case, I want to introduce that constraint into my supply planning algorithm, so that the system would do the adjustments and stick to the input that I gave, that okay, co-packer only do 10,000, and remaining else, you know find another route, maybe push it to the plan 2, or maybe you might end up with some shortages, or etc etc. That's adjusting the plan. I think it's a scenario 3. And what do we have? Receipts balancing. It's scenario 4. We'll see it. What is receipts balancing? So we can balance the receipt, so that we can we can avoid oversupply, or we can avoid the insufficient supply. Because it's just the quotas, and they're just the numbers, and they're just splits, and system does the split. And but in real time scenario, it is a real supply chain physical network, and then we want to avoid this oversupply and insufficient supply, so we can use the receipts balancing functionality, and can do it. Next is validities. I'll say that this diagram is here, that the plant 1 connected to DC, plant is connected to DC. Now I would say in my next quarter, like maybe in the winter season, this lane is inactive. So, and I'll go and say I'll make it invalid. Now system has to understand the invalid sources, and it has to live with the valid sources, and it has to propagate the demand to the valid sources, and it also has to supply from the valid sources. Let's touch base on these 5 scenarios. And yesterday there was an ask that we wanted to see all the results on one single view. So we'll see that, but it might be a kind of a tricky, because every key figure is in a different planning level. For example, if I'm viewing the capacity key figures, they are at a resource and location, right? And if I'm viewing the consensus demand, they're at a customer level. So now if we're bringing all different key figures, they are all at different levels. Like for example, production plan, when we pick up, it says that the source id has to be there. So it would be kind of a messy, but still, at one single go we'll see all the results, and try to infer some things out of it. And what else? Yesterday, I think Funny has asked about the product substitution. Yes, we have, but unfortunately Heuristic won't support that functionality, and also the supply propagation heuristic won't support that. The optimizer will respect them. We'll touch base on that, Funny, when the substitution comes in. There are two kinds of substitution: product substitution and component substitution. When I say component, it's a raw material. Okay. So here is there is S11. Let's say there is S11A, S11B. The Amazon wants 1,000 units of S11A. S11A, we cannot do a supply because the capacities are not there. That has been occupied, etc., etc. But there is S11B. If I tell it to the system that S11A and S11B are substitute products, then the system would opt for S11B and does the shipment of S11B to the Amazon customer, even though he asked for S11A. Second thing, component substitution. Um, to make this S11, you need two different chips, like chip A, chip B, let's say, and then chip A is the actual material that is being mapped inside the bomb, and let's say the chip A is not being available because of the supplier restrictions or whatever. So now, but the chip B is available. So now, if I say that chip A and chip B are substitutable products, and the production would still continue and it will not stop, and it will pick chip B and then continue with the production plan. Okay, we'll see that when the optimizer stuff are starting. Okay, guys, are you guys with me? Yes,
Yes,
Funny also is asking a different question. Yeah, safety days of supply and period lot sizing for planning. If you cover that, will great too. If not, just concepts. Sure, boss. Yes, I will cover, because I don't want to bombard it in the heuristic itself. When we go to the supply propagation, we'll definitely see all kinds of lot sizing. There are 5 kinds of lot sizings, or 4 kinds of lot sizings, I would say. So we'll see how each lot sizing will influence the supply planning algorithm, and yeah. Okay, so yeah, let's change our network, and try to introduce our the co-packer here. So let's bring this co-packer in here, or in here. We have enough space here. So I'll give a name to it. So guys, just keep following it, because I'm going to introduce one location, and you can see the domino effect of this location on the entire supply chain. So we will set up it from the scratch. Okay, S11, I'll say it is a co-packer. So the plan 2 can also, I mean, it can also get some stuff from co-packer. Okay, and now let me start playing with the master data. So first, what should I do? First, I need to introduce this location. So I am opening this location master data, edit mode. Now what else I need to do? I need to extend this product to the co-packer. Let's say location product. And then when I'm extending, I'll also include that this co-packer S11, they belong to our network, the network of S11 subnetwork. Remember yesterday we made subnetwork also. So, and we'll also do that in location product. And then we need a location source. That means we have to say that co-packer is sending it to plan 2. Okay, and that's it. Okay, it's called S11 co-packer. Going into the location product master data and extending the product to the co-packer. Where is our S11? This here is our S11. I'll pick up the plant 2, product is S11. I'll say it 1. So, I mean, if you have followed it up carefully, I gave a ratio of 1, which is not correct. System would throw an error. I want to show it to you guys. Okay, that's it. Running the heuristic now, just introduce one location and then mapped the product to the location, and also created a transportation lane connecting my plant 2 to the co-packer. Okay, now running the algorithm. Going to the run and picking my SNOP operators. It will list all the available operators. I'll pick my heuristic and I can choose a time horizon, not worrying about it now. Scenarios, versions, everything is base. Picking up my subnetwork S11, clicking on next, not leaving any comment, just running it. It is scheduled. Going to the status, checking the SNOP operators again. It will list all the SNOP operators that were scheduled and with their statuses. Now it is scheduled. Okay, it failed. There's a business log, so let me open the business log and see why it got failed. Still processing. Still processing. Come on. You can keep a filter so that you can just see, you know, see the particular details that you want. For example, if we have a couple of products, just put a filter on just the product, and then choose the logs for only that particular product. But let's look at it for the entire, thing. Okay, so see, severity, information, error, some will have warnings. So the job is being scheduled on this planning area, test config, the operator job template of the type of SNOP operator, time horizon is technical and rolling at 105 periods from 0 to future 104 periods. It started and execution severity is failed, and then these are the details where it got failed. There are so many combinations. And what is error message here? It is saying that invalid sourcing. Sum of quotas is a 2.0 outside of allowed deviation. So for this product S11, for this location plant 2, and the deviation is the quotas is 2. Why the quotas is 2? Why? Because, you know sources of supplies, 3 master data: customer source of supply, location source of supply, production source of supply. For this location plant 2, for this product S11, there are 2 sources of supplies that we have configured. First, initially we maintained a bomb. That means there is a production source of supply, and now we introduced another location source of supply, that is co-packer. So now system thinks that at plant 2 for S11 product there are 2 options: either I can internally produce or I can procure it from outside. Now you're saying that the internal production source header, you maintain the ratios as 1, and again for the co-packer, which is the location source of supply, you maintain the ratio as 1. So the sum is 2, which is greater than the allowed deviation, which is 1. So that's why if the demand on plant 2 for S11 is 100, now how this 100 has to be distributed? So you're saying give 1 to my production and give 1 to my um, for locations of supply. Not going to work, right? So now we have to bring it down. We have to make sure that the summation is 1. So I'll do one thing. I'll give a point 6 to the co-packer. Now I'll come here in the ratios. So I'll say here this is 0.6 for plant 2, and I also bring down the production ratios to 0.4, so that the summation would be 0.6 and 0.4, that is 1. So with this, that means 60% of the demand system would do an internal production, and 40% of the demand it will get it from the co-packer. S11, this is a plant 2 S11 product, coefficients of 1, and then come here. Where is the ratio? So here in the ratios, I'll say this is 0.4. Yes, saving it. Now before this, guys, I just want to show it to you something. So if I go to procurement type is X, where do we set that? That is, it can be made. No, here funny, it works in a different way. We have as I told yesterday, there are 3 type of sourcings. One is a P, U, C. Come on, just quickly touch this, guys. So source type is P. That means you are doing internal production. U, that is unspecified external procurement. It is unspecified. Who's giving it? No idea. What is the capacity is no idea. If I just say that we have actually configured that to make the finished good S11 I need earphones. I think every finished good needs an earphone, and I don't want to know who's giving me the earphones, but I'll just say, but that goes in the bomb structure, and everything that goes in the bomb structure we have to say where it is getting sourced from. So there is a chip component. Chip is given by Intel, taken care of. We have also introduced earphones in the bomb structure. Now we have to tell it to the system that who's giving these earphones. I don't know who's giving, which vendor, no idea. So now what I'll do is I'll go and maintain another record in the production source header. In this plant, for this product headphones, this is my source ID, and the source type is U. That means it is unspecified external procurement. And then there's something called as a C. That means it's a co-production. So we don't have any byproduct or that scenarios. This is just a co-production. So if I produce a S11, I might get some metal scrap or something. So that is my co-product. And then system also creates some stock for the co-product, and that's it. So that's all. Nothing else in co-production. In case of optimizer, we can also put some demand on the co-product. So 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 yeah. So these are the three options that are available. Plan 2 in our case was a P, I believe. Did we change before we added co-packer? No, it is still P. So you see, it is always P. I mean, that product is getting both internally, manufactured and then externally procured. When it is internally manufactured, you have to tell to the system what is the source ID. So that's why I maintained this. I said that plant 2 S11, this is my source ID, and it gives a output coefficient of 1, and then it requires earphones. It requires this chip. I maintained all that here, and then I also maintained a resource. I mapped this source ID to that resource. I mentioned that how much of capacity it would consume, blah blah blah, and I said that this is a internal this thing. So that's it. This records ends in here. But on top of it, I can also create another transportation lane, and then I can specify that this co-packer is sending it. So that terminology is like not there. I mean, we don't market X saying like this is more in-house and exhaust. That setting is not there in IBP. So it's like we maintain it individually, all the sources of supplies, whether it's a production source or it's a location source, we maintain it. If you're dealing with heuristics, make sure that all the sources summation is equal to 1. If not, we'll get this kind of a failure. You can have 5 locations who are supplying that location, who are supplying that product to you. You have 3 bombs inside your plant itself, 3 ways to produce it. So now you have 8 options, 5 location source of supply options, 3 production source of supply options. All these 8 quotas has to sum to 1, then heuristic will pass. Okay. Yeah, so what I want to show it to you guys, I want to show it to you the demand on this particular plant 2 location before rerunning the mm, mm, just from this location perspective. So I'll bring the source ID. I'm saying that these are the planning level that I selected. What is my product? S11. What is my location? I'll filter on the plant 2. What is the source ID? The source ID for S11 product. And yeah, I'll also bring the ship from location for now. Okay. Uh, and then I want to see what is the entire demand. Uh, 1 second, guys. Okay, I'll say dependent demand. How much is a demand that is dependent from another connecting locations? So that means the demands are coming from warehouse 1, warehouse 2, and again further connected to the customers, right? So in our this network, and then this is supply chain network, and plant 2 can have the demands from this location, from this location, this location, this location. So it is having dependent demands from other locations. And it also has another option called independent demand, which we didn't maintain. So independent demand is independent to that location itself. I'm just bringing dependent demand, and I'll say what is my production receipts, that how much I'm doing it. So I'll just first bring that down so that we'll see. Before introducing the co-packer, let me filter on the first. Let me filter on the product IDs, guys. Filter on this attribute. Just need the S11 finished good, and just need the plant 2. S11, where is S11? Plant 2. Okay, so we can see here, Shifram, let me hide this for a moment. S11 product inside the plant 2, the dependent demand is 1200. So there is only one source ID. That's why it is being shifted to 1200, because earlier the ratio is 1. If I have production version 2, production version 3, if I maintain the ratios accordingly, 1200 would be split across the 3 production versions. So now what we did, we introduced another location source of supply, a co-packer, maintain the ratios accordingly. So now we'll also see how that will impact. I'm rerunning it now. Heuristic S11 next run. Get it finished. Okay, the demands also have been changed. So based on the new run, I think yesterday we are doing something, we introduced some constraints. So but we didn't run the heuristic after that. Now is a fresh run. We gave a fresh run. So this is the dependent demand 973, and then 595. So it didn't pushed the entire demand onto the source ID itself, right? So if I bring out the, where is this hidden one? Let me go and bring out the transport receipts. That means how much is been so you see here, um, first key figure dependent demand is 973, and out of that 378 has been pushed to the co-packer, and 595 is pushed onto the source ID. Okay, so that's how we can introduce a co-packer, and then do both the in-house production and external procurement. So, and if I bring out the co-packer also, I can see the dependent demand of 378 on the co-packer, and it pushed 378 to the plant 2. So yeah, just a quick summary on this scenario. What we did, we bought another location co-packer, we pushed it to another connecting location plant 2, maintained the master data, gave inappropriate ratios, ran the heuristic, failed, uh, adjusted the ratios. The thumb rule is that for any unique combination of location and product, all the sourcing options, if I sum up the ratios, it has to be 1. So I gave accordingly. I gave some weightage to my co-packer, another weightage to my plant, and reran it. I can see the results there. Okay. So now let me bring out the lead times. I mean, let's build on this scenario itself. Like, let's take this co-packer and then this plant 1. So because right now, let me this thing. Let me just bring down the plant also. Where is my co-packer? So now system would also show the dependent demand on co-packer. Okay, so See here, location is co-packer, dependent demand is 378. So guys, it will come as none, none, none. Why? Because the key figure dependent demand is configured at product location. Dependent demand doesn't understand what is a ship from location nor the source IDs. So that's why it would show none and none. Okay, so that's a challenge. So that's why that's what I'm mentioning, that if you bring all key figures onto one single view, this is what we'll get, too many nuns. So might take some time. So that's why we should, put them in different workbooks, and then dedicate all specific planning levels to all single planning level specific key figures to one view, and etc. So co-packer has a demand of 378 on week 18, and then plan 2 has a demand of 973. Co-packer has sent 378 to plant 02. That's why you can see here this transport receipts. Product is S11, location ID, that means it is a receiving location, plant 2. Source address is nothing, 0, but the ship from location is co-packer. It sent 378. Demand was hit on week 18, shipment happened on week 18, that's why it received on 318. What if there is a lead time of 1 week? Now let's see what happens if I introduce a lead time of 1 week. That means we are jumping into the scenario 2. Okay, so opening the transportation lane. Where is our, yeah, co-packer sending to plant 2, product S11, the lead time is 1. Saving it.
But
Yeah, someone has it out, please shoot.
um, is that lead time is in a days or it's in a week?
It's in a week right now. Why? Because the supply planning is getting run on week.
Oh, okay.
Okay, so the lead times always looks from at what level you're doing the supply planning, and accordingly we have to maintain. And you actually asked a very good question, thanks for that. So this is actually triggering the lead times, actually triggering the businesses to go for a daily level planning. So I thought of covering it in the optimizer scenarios. Why? Because if it isn't really days, the co-packer takes 2 days to send it to the plant. Now I'm maintaining it as 1. So for that I need to maintain it as 0.2 or something. But there's a catch that the lead time, it's an integer. So you see, I kept my cursor on the lead time cell. It is showing lead time. It is optional and it is an integer. The moment I kept 0.1, I save it, it will fail. Okay, so that's why I mean lead times, all the production lead times, customer sourcing lead times, and location sourcing lead times. So this is kind of a one, factor. That's why the plan, the businesses are going to daily level planning. All the projects that I have worked, everyone has gone for daily level planning. How to go for daily level planning? We'll cover it. It's a huge exercise. We need to change the entire planning levels of the supply planning key figures. There are like 120 odd key figures that are related to the supply planning. Summation of the inputs, indirect inputs, outputs of the supply planning algorithms, 120. We need to go to every key figure, take out the every planning level, and then all these 120 key figures, they belongs to some 40 odd planning levels. Weak prod location, weak prod customer, weak prod resource, weak prod resource source ID, etc., etc. There are I think there are 25, I think, to 25, 22. So 22 planning levels are there. You have to go to every planning level, carefully change the time dimension, switch it onto the daily level, and then carefully save it and then activate it. You'll get some errors saying that you haven't configured it properly. There is an inconsistency. Some key figures are at week, some are at day. What is this? So you need to go and fix it. So once you're done with that, create your profile for optimizer or for a heuristic at a daily level, and then run it. and then you can maintain the data from a day perspective, and then you will see the results at a daily level. Okay, so yeah, for now I just gave one. That means the lead time is one. So now I'm rerunning it. Heuristic S11. Let me open the view in technical weeks, not at the calendar weeks. Technical week is where you specify that, you know, sometimes a week goes, the week intersects between 2 months, right? Like for example, the last week of, for example, this April itself. So here we can see that these 2 days, if I say the April of 2019, it has week 1, week 2, week 3, week 4, week 5. But in week 5, 2 days are getting into the April month. Next 5 days are getting into the month of May. So what I'll do is, with technical weeks, I'll say this is technical week 1, technical week 2, technical week 3, technical week 4, technical week 5A. It will have only 2 days. And technical week 5B will have these 5 days, and then technical week 6 and 7, so on and so forth, so that, you know, when we do the aggregation, system won't give any skewed results. So we will go there, but yeah, for now, these are the results. I'm opening at a technical week level. Okay, so the status is done, it is finished. Yeah, it is finished. So now let me bring up the supply also. So now this is the thing, guys. I want to show it to you that, you know, there's something called transport supply. So should I open it in a different tab? Let me open it in a different sheet. Ship to location. I will unselect all these capacity related key figures. I want to see my dependent demand at the co-packer, and then how much it has shipped. Okay, and then I'll put a filter. Yes, Krishna. No, but this is not this, but I want to choose the S11 co-packer. Hmm. It is still showing same thing. So what happened? The lead times haven't changed. Didn't I press the save button there? Location, source, edit mode. Okay. Product ID is S11. Think we didn't press the save button there, or did we? We did. Co-packer. Um, co-packer is to plan tools. So one. So it has started on technical week 18B. That means transport supply. That means this location co-packer for this product S11, it is shipping it to plant 2 on 18B, and 19 it has sent 36, 20 it has sent 36. So if I go to this space here, so now it is receiving 378 on plant 2. Why is it like this? Is it the, I think, oh yeah. So yes. Hey,
Can
one
you
second,
close and
guys.
reopen maybe?
Yeah, no, I mean, so what happened is I ran it at a weak level. That's why it has also considered the 18A. Okay, so let me do one thing. So I'll just take off all these demands. One second, guys. Just deleting all the demands from customer, just to make the results, clear and clean. Um, and we need to take off the independent demand also. Let me go back to the backend and delete, because we maintain some independent demand at the warehouse one yesterday. So we wanted to show you guys that we can also maintain the demands from. Need to choose the right planning level. This is not the planning level. Our planning level is week prod lock. Every week, every product, every location, starting from 2017. Let's come to the 2019, the current week. This is a one, and dependent demand. Okay, let me go to the week 8 also. Okay, enter a valid value. What does it mean?
Capital
Filter.
S level.
Yes. Thanks for that. Okay, warehouse one, we maintain a demand of 100. Let's take this off, and then I would say that let's keep a demand on warehouse two on week 19 of 100, week 20 100, and yeah, this 100 here. Now let's just deal only from a warehouse two and co-packer. Let's play within these locations. Okay, I'm coming here, going to the edit view. I'll also bring the independent demand so that we'll see uh, the independent demand on warehouse two. Oh, I'm sorry. I think I should maintain it at the
But
plan
still you
two.
are planning in a, but still you are
Sorry.
planning at a week level, right? You said you are going to plan at a daily level. So that means your demand also should be on a daily level.
I'm sorry. What's that? Can you please come again?
You, you, you are maintaining your demand at a weekly level, right? Right now,
Yes.
independent demand
Yes.
and the
Yes.
demand.
Yes. Yes.
Earlier you said you were going to maintain at a daily level.
No. So what I said is that uh, in all the three implementations that I have done, the requirement is to get into the daily level. Okay, that's a consumer good, so the days are very sensitive, so that's why we have reconfigured
Okay.
the entire engine and we brought them into daily level. So if I'm saying week, I cannot actually go to further down because the week is a base, so we cannot go down, but we can go up: week, month, quarter, year, etc. Okay, so there we changed everything at daily level, so we can actually put the demands at daily level. And then the lead times would be, I mean, if I maintain lead time as 3, that means the system considers it 3 days, because the system was configured at day, and then the optimizer profile is also configured at day level. So that's the thing I mentioned. So refreshing it, now we should be seeing some demand on plant 2. Yes, the independent is demand is 100. These are the previous results. Now let me rerun so that also I'll take this off, guys, 1 second. So we can complicate the model going further, but not now. Just want to keep things simple. So rerunning it, so all these other dependent demands would get lost, because I took off all the. 1 second, guys. I think there is still demand left at the customer side. I couldn't able to delete from the front end because it is saying this is actually in current week. So current week you cannot touch. I can very well touch if I do it from the back end. Or the master data workbook, choosing the planning level for the consensus demand, that is at week prod customer. So this is a week prod customer, and then there are 12 key figures that are configured at this level: marketing forecast and customer demand, delivery rate, etc., etc. Selecting the consensus demand, this is what I'm interested in, and I'll take off. See, Amazon and eBay, there are this maintain, take this off, saving it, so that in our supply chain there is no demand anywhere. The demand is only at the plant 2, and then the plant 2 has two options to source: internal manufacturing and external procurement from the co-packer. Running the heuristic once again. Heuristic S11.
Look at these planning operators are standard or these are configurable.
These are standard. The supply planning, they are standard. But if we want to come up with more key figures and more calculations, we have to create a custom planning level and then create the custom key figure. For example, the production plan is at the SKU level, product ID level. If there is a requirement that I want to see how much of my production related to a particular brand is happening, and I want to sum it up with with the actual demand and minus the some stocks. So there is this kind of a requirement that is there, and they want to view only at a brand level. So in that scenario, we have to create a new planning level that is called week brand and location. And if the ask is that I am not interested at a particular location but at a location region level, for example, all my southeast, southwest, etc., and in that case we have to create a new planning level that is a week brand location region, and then create a key figure and write the logic for it, that please summation of the production plan plus some other demands minus the stocks, and so that that key figure can be used for reportings, etc., etc. And that key figure takes the calculation from the supply planning results.
So who
So we can
usually write these logics, like
we
the
have,
technical?
yeah, we have to write it. So everything related to IBP, we own it. So and actually, yeah, I mean, I should have touch based all those planning levels and etc., but because of the participants request, we jumped onto the supply planning. So but yes, we'll very well spend almost like more than a week on modeling the entire system first, how to model a master data attribute key figure planning levels, and come up with this all these fancy calculations, that if I have data at a product ID level, and how I can bring it up to the brand level and compare it with another key figure which is also at a brand level, and I want to do some subtraction and then populate a value in some other key figure, and etc., etc. We'll see all that. Okay, so So strange, guys. So the independent demand is 100. It is not propagating it to the dependent demand. It is also not doing any production. Why? Did we maintain any ratios, etc.? 1 second. Any ratio time series indicator? Nope. Let me open the production source header. Oh yeah. So yeah, why it is happening like this, I'll tell you guys. So because in the customer source, we said the sourcings has to be read from the key figure called customer sourcing ratio, and we haven't maintained any of the ratios there. So see here, the ratio time series indicator. Am I audible to you guys?
Yes, Venkat.
Yes.
Hello. Yeah, sure. So yesterday what we did is, instead of taking the ratios from the master data element, we marked all this as X so that system can read the ratios from the key figure. But yesterday in the key figure, we maintained ratios for only two time periods, but for future periods we didn't maintain anything. That's why the demand is not propagating from customer side. So I'm taking off this. Okay, so now system can read the quotas from this ratio itself, so that it will give us some results. Do we have an F1 help on any of the columns? Nope. But we have Google, and Google is having a lot of the content already on IBP. Yes, it is done. Come back here, refresh. Okay, crazy. It is still the same. Why? Why the demands? Why the production is not happening? Is there anywhere else I maintain this as? Right. Yeah, let me see if it got saved or not. Yeah, I've taken off this indicator. Yes, okay, guys. I mean, just don't want to waste time on this. Maybe there is some testing that I have done, before the session, might have made, some change, and that is restricting us to give these results. But just please make a note of it. Tomorrow we'll see why the results are not coming. I'll not do any changes. Like whatever changes I'll do, I'll also explain it to you guys. So, but the concept here is what I wanted to show it to you guys is that if the demand is 100 here on the plan 2, this is an input. Once I run the heuristic, system looks for all the demand elements across the network, customers, connecting locations. It will create this dependent demand, and out of this dependent demand, it will push some for the production source header master data, because we maintain the ratios accordingly, and some for the co-packer, the material. And the point that I wanted to highlight is if the lead time is 1, so if the, like for example, if the ratio is 0.5 for co-packer, the dependent demand at a co-packer would be 50 here. Okay, so now this 50, the dependent demand would be on not on week 20, but it would be on week 19. Why? Because the lead time is 1. So to make the 50 units to reach on week 20, it has to do the production on week 19 here. Okay, so that's one. And second thing that I wanted to highlight is that the transport supply, the dependent demand would be 50 here, and then the transport supply would happen on week 19, and the transport supply key figure is from a shipping location perspective, supplying location perspective. That's why the key figure is ending with the name supply. So here if you see location ID, this is from a co-packer perspective. Week 19 it is moving in. But if I want to view it from a receiving location perspective, I have to visit the key figure called as a transport receipts. So if I come in here, so you can see the transport receipts. Here the location is plant, that is a receiving location. Ship from became a co-packer. 50 would be come and sit here. So that's what I want to show it to you guys. Any doubts in this?
No, Venkat.
Okay, great. So yeah, just a quick recap. 2 sets of key figures: transport supply, transport receipts. 2 sets of key figures from customer dimension: customer supply, customer receipts. When I say customer supply, you have to view the data from a location ID perspective, that from warehouse perspective, when the goods are leaving my location. If the lead time is 3 weeks, and on 4th week, in the key figure called as a customer receipts, from a customer perspective, you will see that that particular stock is being received on week 4, and who is shipping it? The warehouse is shipping it. Same in the case of location sources also. Transport supply, transport receipts. Transport supply is from a supplying location perspective. That means the location ID becomes the the supplying location. Here the location ID is a co-packer. When you're saying receipts, the location ID becomes the receiving location. So that's why the plant 2 becomes this. Okay, so and we'll see why this thing is not happening. I don't know what settings I've made, but yeah, so that's one. So next is manually adjusting the plan. So like, what is this thing? So manual adjusting the plan. So now we're getting into the third scenario. So now here, I received a particular input that between these 2 locations only this much will be shipped. So I'll go and I'll manually adjust the plan that, okay, now please don't give me anything more than this. I'm entering an absolute value. Supply planning, you respect it, and both the heuristics and optimizer really respects this adjusted key figures. So manual adjustment that enables planners to fix the values of transport receipts. And other thing for the production, so adjusted production. And there's also another thing for adjusted customer receipts. So you can adjust both the 3 things, both the location, transportation, production, and then the customer. Okay, so this slide is more from a transportation perspective, guys. So how fixed from a receiving location standpoint, like if you're saying adjusted transport receipts, that means you're from a receiving location perspective, you're going and saying that, okay, I need 100 on week 4, and I don't care when you're going to start your your shipping. So adjustments would be respected regardless if ship from location is able to ship originally calculated quantity or more. I mean, it can do more, or it might do less. I made the adjustment as 100. You have to give me 100. Even if it is 30, or you can do only 30, but I don't care. I just need 100. Even if you're ready to give 200 because of the demand, etc. But still, I need only 100. it respects that irrespective of the original demand that is there, and regardless if the receiving location need more or less. Again, receiving location warehouse, the demand in warehouse is 500, but I'm going and adjusting the plan as 100. So if I give the adjustment as 100, it should actually give me only 100. Okay, and then both heuristic and optimizer respects this. So let me quickly go and bring the results. So don't, I mean, just forget about the co-packer and plan 2 guys. Let's deal with the this side of the supply chain, like Amazon warehouse and plant 1. Let me punch in some demands here. So I'm saving it. Yeah, just this the Amazon. Let's do for the Amazon. So let me run. You haven't saved all your planning views, that's fine, because we entered 50-50 there, right? So it is just giving an error. Schedule. So now I want to view from the if I go to this network, Amazon is connected to warehouse 1, and warehouse 1 is connected to plant 1 and plant 2. So I'll maintain this node plant 1 to warehouse 1, and we'll see what is the result, and we'll go and put some adjustments on top of it, and we'll see how it this thing. So transportation. So I'm editing the view. I have product ID, location, ship from would be plant, location would be warehouse. So I'll bring up the relevant key figures. First, I want to see the demands at both the warehouse and the plant. And I'll see the transport receipts and then the adjusted transport receipts. Okay, and then I'll go here. What should I say? So just leave it as it is. Okay, there are so many. So I think the results are done. So now let's analyze it step by step. Let me also bring the customer so that we can have the entire view. The customer here, and then I want the consensus demand, and I also want the customer receipts. Okay, cluttered view. Let me filter it down so that we'll see. I don't want eBay, so delete filtering it down on the eBay. Just the Amazon. Where is Amazon? Okay, I think I filled customer ID filter on this attribute. Where is Amazon? Oh, okay, it is showing me the ship from locations. That's fine. So let me do it from here. Customer is Amazon, and locations ID is I want to view my warehouse 1, warehouse 2, and then plant 1, and that's it. Okay, first row 5. Product ID is S11, location none, ship from none, customer is Amazon. The demand is 1000 on week 19, 1000 on week 20, 1000. Okay, so now let's go to the dependent demands at warehouse 1. So plant 1 is coming unnecessarily. So we can see here the warehouse 1, the dependent demand is 500, and warehouse 2, the dependent demand is 500. Why? Because of the because of the ratios that we maintain, 0.5, 0.5. Remember that? So that's why the 1,000 demand is being split, 0.5 to warehouse 1, 0.5 to warehouse 2. Okay, so now this 500, the warehouse is further splitting to plant 1 and plant 2. So what is the ratios that was being maintained for, let me quickly open that. It's called location source. The product ID is S11. Ratios. Okay, it is okay. I maintained crazy value, so should have maintained it simpler. Okay, let me filter on warehouse 1 so that okay, warehouse 1 product S11, it is getting from both the locations, plant 1, plant 2. I gave 0.4 to plant 1, 0.6 to the plant 2. So if I come here, so plant 1 is getting 450, and I think I should bring a plant 2 also. Why it is going to the product, guys? I'm not sure. Okay, so plant 1 got 450. Why? Because warehouse 1 500, out of 500, 0.4 is been split to plant 1, and for the warehouse 2, for the plant 1, 0.5 is been split. So 0.4 of 500, 0.5 of 500, the summation is 450. And same in here. Are you guys with me till now?
So this is no. You said like 450 plus 550, right? Like, yeah. Can you explain that logic once again?
Sure.
Sorry.
Yeah, sure. So yeah, I'm opening the dependent demand key figure, guys. That is the aggregated view of the entire dependent demands. But instead of dependent demand, let me open the dependent location demand. That means how much of the dependent demand that is coming from a connecting location. So if I bring that up, you guys will also see from which location this demand is coming in. So I'm editing the view and I'm taking off the dependent demand key figure. So take off this dependent demand. So now I think now it makes more sense. Let's see that. The dependent demand I need to bring location to. So yeah, so one second. I'm copying the current sheet. One second, guys. Just let's deal it in silo so that it makes more sense to us. Take off this customer. Just the dependent demand. Okay, now say it, guys. So 1,000 is a demanded customer Amazon, 0.5 0.5 split. Warehouse 1 got 500s here. Let me color code this. Warehouse 2 got 500 demand as per the ratios. Now warehouse has to propagate the demand of 500 to its connecting locations. It doesn't have any production source header, so it cannot do production in itself. It has to propagate the demand to its plant 1 and plant 2. So how it is propagating 500 demand to the plant 1 and plant 2? So as per the master data that I have maintained here, warehouse 1 has to do 0.4 to plant 1, and warehouse 2 has to do 0.5 to plant 1. So now of this 500 from warehouse 1, if I go to the other view here, dependent location demand in here, so it received 200 on plant 1, say this, and 300 in here.
Yeah, it makes.
Okay. Yes. So warehouse 2 again, that is a 0.5, so it's split equally. So this is 250, this is 250. Now from a plant 1 perspective, I do the summation here, that is 450. That's why the dependent demand became 450, because the dependent demand, it shows an aggregated, view. So it doesn't look for what locations the demand is coming in. It just shows that this is the demand, overall demand on this location, and the demand might be coming from 10 different locations, but don't care. Dependent demand, this is aggregated view. But if you go to dependent location demand, it shows the location from where the demand is coming in. So now let's come back to this view here. So 450 is the demand, and so come to the transport receipts, guys. Just please focus on this area. 500 is a demand. Plant 1 did a transportation of 200. Plant 2 did a transportation of 500. Okay, so now I'll go and say the transport, adjusted transport is 111 here. Just giving a random value, saving it. Okay, 111 here, 111 here. Now I'm running the heuristic. Now the supply plan would be based on the the adjusted value that I have entered here. It's finished already. So you see here, I maintained the adjusted as a 111 here, so that the transportation receipts also became 111 here. So you see here transport. So again here, transport receipts I mentioned week 20 as 111 here for plant 2, and then the transport became 111 here. Just want to highlight one small thing here, but you can still see that customer receipts is still 500. That means warehouse 1 is still sending 500, because that is a demand on that particular location. Because if you remember this slide, this is infinite demand in supply plan with no shortages. So there are no shortages. So even though I adjusted my plan, and it still said that you have to send 500. And what happened to the remaining stuff? So the plant is sending only
We adjusted to 111, right? So
yes, yes.
that is already greater than this. So what is the case if we adjusted to the bigger quantity, like greater than 500?
No, I mean it is less than, right? So plant 1, I'm saying send only 111. Plant 2, you are sending 300 to warehouse 1. The summation is 411, but I'm still short of some 89 quantities.
Right.
Right. Demand is 1000 as per the ratios. 500 demand came to the warehouse 1. 500 again is pushed back to 2 plants. I adjusted my plant 1 shipment. Warehouse 1 will not receive the entire quantity that it has requested. It requested 500, but it is receiving only 111 plus 300. So total it is receiving 411, but still it is not stopping itself. It is sending 500 to the customer. What happened to the remaining quantity? That we'll see in a different key figure that is called projected stock. The projected stocks would be in negative. Now it says that you are short of this much stock. Okay, so let me just this view, guys, if you see here. So here 111 is been received from plant 1, but it still sent 500 to the Amazon customer. You see this, and then on this week minus 142 is the negative projected stock that you incurred if you do the shipment, because I cannot compromise on the supply. Heuristic does the infinite demand and supply, but if you're adjusting the plan and making under supply, the stocks would be projected in negatives, so that the planner will know that if I go with this approach, I'll need more of 142 stock on week 20 at this location of warehouse for this particular product of S11. Now you guys with me now? Silence.
Yeah, bit confused.
Okay, at least understand the theory. So the theory is that heuristic will not stop with the supply shortages, with your constraints. Heuristics will always meet the demand, period. You say infinity is my demand, it says infinity is the supply. But if you really dig deep into the supply chain and see that, okay, which all locations have actually supplied the quantity of infinity, there you will see these potholes, you will see these negative stocks across your locations, and etc etc. But the supply, it says that in order to meet infinity, the warehouse has to do the shipment of infinity. The warehouse is connected to a production you have to do infinity, and it says all that. But you will see all these negative projected stocks and all these shortages inside your supply chain network, so that the planner can work upon that. The planner will go and think that if I want to meet all my demand, these are the bottlenecks that I have inside my supply chain. I will incur excess capacity utilizations more than 100%. The plant will end up producing more, and I'll end up getting all these negative stocks at these locations, so that I have to do something to increase my stock level on that location. Can we rerun heuristics to plan with the delta to cover shortage again? But still, it is will still incur this much negative projected stock. So whatever delta is there, it was still there. So only thing that we have to do is maybe put some, increase the inventory targets, and etc etc, and the system would try to do some pre-building of the stock maybe in week 18, or so that the stock would be projected for future. Maybe on week 18 it will do more production, on week 18 it does more shipment, in week 18 it makes sure that warehouse 1 will have enough stock, so that this negative projections will not happen. So that's a decision that the planner has to take. So, and which element that he wants to tweak in. Okay, so yeah, the time is already up, guys. So
Yep.
I think what else we have here. So receipts balancing we'll see, and then validities also we'll see. Um, so yeah, so let me quickly show it to you guys. What is a validity? So we have 3 sources of supplies: location source of supply, production source of supply. One is a location source of supply, and next is a customer source of supply, and then the production source of supply. So, and you can, out of all the sourcing options, you can say which one is valid, which one is invalid. So warehouse 1 is connected to 2 plants. You can go and say on this particular period, plant 2 is inactive. it is not valid anymore. Production source of supply, you have 5 bombs for one single product. You can go and say that my bomb 4 and bomb 5, source ID 4, source ID 5, they are inactive. Now optimizer will propagate the demands to the active valid sourcing options. So let me go in here, let me maintain that. I'll open the customer source for the product S11, and I'll show customer source validity. I think customer source validity is not there. I think it is not being included into the planning area. So, but let's deal with this production source validity and production location source validity. I'm opening location source validity, edit mode. I'll also open the location source here. I'm opening it. So now I'll maintain the validity in here, guys. So let's see. So which one we want to take off? So let's take off the plant 2 and say that this is invalid. I'm coming to the validity in here. There's no data found, that means no records are being maintained. So I'll go and say that my plant 2 to the warehouse 1 sending this product S11. I'll come in here, I'll say this valid from. So now I need to give the timestamps. So let me give like 0401 2019. So, or just maybe just the today. So basically you can choose the from and to, like Q1 Q2 it is invalid, Q3 Q4 it is valid. So just giving this, I'll change the format, always has to be in YYY/mm/DD. So choose this. Why it is not coming like this? This is time. Let's still change. Why it is not changing? Okay, so this is date. Let me go and format cells, custom YYYY/mm/DD. Okay, copy this and paste it here. Okay, so source value 2, it is for eternity. Okay, it is saying that it should be in YYY or it's hyphen. It is saying, okay, let's keep the hyphens. Right click, format cell. Why it is not taking? Yeah, fine guys, I mean I don't want to dig deep into it, but yeah, tomorrow we'll see anyway the validity. So we need to bring it in the right format, then only it will take that values. And if I say that this lane is invalid for this location and product, system would propagate all the demand to plant 1 only, because plant 2 became invalid. So yeah, so just a quick recap on what we have done today. So we have seen the in-house and external production options, guys, and then uh, we received some errors because the quotas are more than 1. We maintained them accordingly, got the results. And then we talked about the lead times, both the supply related key figures and the receipts related key figures. We have seen how the lead time would come in between, and we have seen the adjustments of the plan. So I can go at a particular element and I can adjust my plan. It could be adjusted production or it could be adjusted transportation. Heuristic will agree to it, but still it will end up meeting the entire demand. But we can see the pit holes in between. So if we bring up the projected stocks, we can see the negatives and etc etc. And then we are in short of covering the receipts balancing and then the validities. Okay, guys. So any questions, just please shoot out to the meeting coordinator, or if you have anything, just please let me know. We can discuss it, or I'll cover them for tomorrow's session.
Sure.
Okay. If nothing else, then we can drop off. Tomorrow we'll start with the supply propagation heuristic, and we'll see the difference between the normal heuristic and supply propagation heuristic. And then day after tomorrow, we'll get into the optimizer and cover more scenarios probably in optimizer, because we have so many costs and other things to play with. Okay.
Sure.
Okay.
Thanks.
Thank you, Venkat.
Thanks, guys. Thanks for your time. Bye.